Howdy, everyone. Greetings from another. What do we call it? We call it the marine layer. Another marine layer socked in Santa Cruz today. For those of you who don't know it, we can turn to Mark Twain's famous statement, which was, "The coldest winter I ever spent was the summer in San Francisco." When this marine layer comes in, it's actually quite chilly here. Are you guys getting in the marine layer right now up in British Columbia, or is it nice and sunny?
No, it's quite breezy, but it's sunny and a little cool for this time of year, but that's not a bad thing.
Okay. For those you don't
But
know,
we don't get what you get in San Francisco with the.
I guess, and I'm right on the coast, but you guys are right on the, but you're in the island.
Yeah, we're a little in from the main ocean. Out on the west coast, they get August for sure.
Okay, all right. So for those who don't know, greetings to Martin Davis. You might know him from JTS. You might also know him as The Mountain. He is so magnanimous that, is that the right word I'm using here? Or he's so glorious, I should say, that Felix will be occasionally playing trumpet in the background to announce Martin's presence. Felix has trumpet lessons right now, so we're going to have a little bit of trumpet coming in. Sorry. I told you, it's from my house, and this is my life. But the door is closed, so no dogs today. So Martin Davis, if you don't know him, it probably is actually, besides being the Mountain, not the Game of Thrones Mountain, but besides being the Mountain, is probably most well known for JTS. Would you say that's right? Is that?
Yeah.
Yeah. So for those who don't know what JTS is, it stands for the Java Topology Suite. But I will let Martin. Let me toot your horn for you. Literally.
Go for it.
Okay. So JTS is like the gold standard. Like PostGIS is the gold standard for spatial databases. JTS, I would say, is the gold standard for dealing with topological relationships between features. Is that right?
And just general geometry processing.
Okay, and geometry processing.
Yeah.
So a lot of you have probably actually dealt with GEOS or heard of GEOS, but you probably didn't know that GEOS is really just a port of JTS. JTS came first, way back when, and then they ported that to GEOS. Martin has worked some on GEOS, is that right? You sometimes contribute stuff, or is that just Paul now?
I do, and I'm expecting to do more, but...
Okay. But he still does stuff for JTS as well, and so JTS, and thereby GEOS, and thereby, what's the JavaScript version of JTS called?
JSTS.
Yes, JSTS is all from the G. Wait, what is there? There's also what?
There's NTS, Net Topology Suite.
Okay. So all of that flows from JTS, and that's Martin's biggest claim to fame, I would say. Would you say that's what you're most known for?
I think so. Yeah.
Yeah.
Probably my only claim to fame.
Nope. Martin, come on. Now you're the author for pg-featureserv. Like that's going to eclipse. That's totally going to eclipse JTS. So I wanted to ask you, like, what got you into Java to start with?
Well, back in the mid-90s, I was working for a BC government office doing spatial data processing, and I started playing around with C++ because that was the cool language at the time, and it felt like I thought, okay, this Microsoft is using it. This is the future. This is the best thing. And I actually wrote a little overlay library in C++, which was sort of okay, but kind of painful, you know? And then I heard about this language called Java, and the first thing I heard about it was it had no pointers. And that made me very excited because pointers are just a nightmare.
Yes.
In C++. So I grabbed it and started fooling around with it, and I wrote an applet to display map data, which I thought was pretty cool. And then so fast forward a few years, Java's getting some traction, and the company I was with got a contract to develop what is JTS. Okay. There was a very smart guy here in the BC government who thought that there should be a general geometry library in Java, and I was working on that. Yeah. And that was 20 years ago.
Yeah, and the person that did this must have been very smart. I mean, because they allowed you to open source it too, which was just starting to become it was a big thing, right? There was Netscape and all these others that were like starting to deal with open source, but that's very early on. I mean,
it is,
relatively speaking. I mean, open source has been around since probably the 70s, right? But
yeah.
But in terms of mainstream adoption, that was kind of the beginning of that. Why do you think they chose open source back then?
Well, the guy I'm going to name check him, Dr. Mark Sondheim,
Okay.
who is a good friend of mine, and he is a spatial visionary. He's amazing.
Okay.
He basically invented technology that got FME its start as well. So
Really?
he was involved in a lot of really interesting spatial initiatives. Anyway, and he recognized the value of open source. And if you don't, otherwise you do code for the government and it just disappears into some government black hole. So very, very smart.
Yeah. Well, especially in Canada, right? Well, not I know you just had Canada Day, so I don't want to really bring Canada down. But that is one of the big debates early on between the U.S. and Canada was like open source versus non-open source. I think because your data has never really been open. It's probably finally becoming open source, right? Like open domain.
Yeah, it's been a slow process. There's more open now, but yeah.
Yeah. So I think because I remember like when I was doing my PhD, like I could get all the NASA programs I wanted. Like if they published it, I could just make a request and get it. But I don't. Was it like that in the BC government or?
No,
Yeah.
no, absolutely not.
So
there's still a big debate going on. Unbelievably, here we are 20 years later, and I think finally the tide has turned, and there is a recognition that open source is the way to go. And if you write code for government, that should be opened up as well.
Yeah, exactly. My tax dollars paid for that. Like,
yeah,
which could also bring us into pharma. Like, my tax dollars paid for all the research that went into that. Maybe you shouldn't make $1 billion, but we'll leave that alone for now, because then we'd have to get into American healthcare, and July 4th is coming up, and I don't want to really.
We only have an hour, so.
Yeah, exactly. And so then just one other thing before we get to feature-serv, which people don't worry, we will get to feature-serv. But Martin's such an interesting person, and he's not out and about it. He's not a gadfly like Paul Ramsey, shall we say? So I really want to give a chance to. But he's a really great and interesting guy, and I love working with him. So I really want you to get a chance to know more about him. But we can't spend the whole time because I was going to ask you about your other nickname, which is what? Mountain what?
Oh, my mountain climb.
Yeah,
I used to do a lot of mountaineering and climbing, but hence the picture.
Nice, but we can't. We'll stay focused. We'll stay focused.
All right.
Before coming to Crunchy, I think you were working a government job. Most people don't know that you actually did quite a bit of web development as well, right?
I did, and I was working for a consulting company before I came to Crunchy, and the major project I had there was to develop a web mapping framework for the BC government, sort of a general purpose web mapping framework,
right?
Which was based on OpenLayers, but it needed to go. OpenLayers is just code, right? And this needed to have a user interface and easy configuration, and basically it was a web component. Before there were really web components, the idea was you could just drop this into any website and bingo, you got a map.
Right. You just pointed at whatever your maps, wherever you just set the URLs for your map services, and then it would
exactly. Yeah. And so that was a pretty deep dive into JavaScript.
I bet.
Pretty fun, doing UI stuff is really, really fun. JavaScript is half fun, half insanity. So.
Yeah, especially when you do it for the web too, right? Because you're like, the debug process becomes even, and how this browser does its JavaScript versus, right? So, yeah.
Happiest day of my life in that project was when they said, actually, we don't need to develop for IE8 anymore.
I bet. So many people. I mean, it's amazing in government how much IE is still to this day, like not even supported by Microsoft, but still around.
Yeah.
So, all right. So now you've worked in Go for feature-serv, because Go is part of this PostGIS FTW, PostGIS for the win, right?
And for the web.
Oh, right, for the web too. But for the win!
Yeah.
But so did you enjoy Go as much as Paul did?
Oh, absolutely. Yeah, Go was a fabulous experience. I mean, I started from zero, and within a week, I felt like I was being quite productive.
Oh,
and
nice.
That's just the whole experience was really pleasant.
So do you think that's because, as a developer relations person, this now starts to interest me. Like, do you feel like that's because the language is so well designed and there's like good libraries to go with it? Or was there really good doc and examples? Or what do you think? Or was it all of it?
All of the above. Yeah. I mean, it's a really elegant, simple language, but it's powerful enough to do everything you need to do, especially for web service kind of things.
Okay.
And yeah, there's a great libraries available. The build process is super simple.
Okay.
Spits out an exe, runs, it's it's just a really pleasant experience. And I mean, I'm still a Java guy,
Right.
but I have to say, Java was so early to the table that it's sort of build chain and tooling is quite a bit more complicated. And I think the trend now would Go, and I think Rust is doing that, is you just have one build chain, you make it as simple as possible,
right?
And it removes a whole bunch of pain points.
Yeah, like Maven. Reduces
yeah.
Right. Exactly. Right, like Maven's incredibly powerful, but I have yet to get it to work right every time. Like it'll work right 80% of the time. You're like, why didn't you get my dependencies that I needed, or I update like so. Yeah. That is that part I find painful. I haven't used Groovy yet. People say that like Gradle, doing Gradle builds is supposed to be better, but
yeah, I haven't tried that either. But yeah, and hopefully it is better. Yeah.
Okay. Well, so that's enough of the general chat. Should we get to pg-featureserv?
Yeah, you bet.
Okay. So pg-featureserv is part of this crunchy spatial suite that we've developed. It is open source as well. In the show notes, I'll put the link to the GitHub repo. It's basically the same as the tileserv one. It's crunchy data / pg_featureserv with no e on the end of the serve, right? That's because we're hip and new. We tried for the .io, but we just decided dropping the e was hip enough, right?
That's right. Maybe we should have gone for the .ai though.
No, that's the new one, right? Yep. Yeah. .tv is so old. Yeah. It's also written in Go. It's again highly opinionated. That it assumes all of your data is going to be in PostGIS. But because we did that, we get to leverage PostGIS, or you got to leverage PostGIS for a lot of this stuff. It's also super lightweight, right? So do you want to talk a little bit about how lightweight it is, or what the idea is behind it, or do you want me to?
Yeah, well, like you say, it's by virtue of the fact that we're only looking at a PostGIS instance, and we're basically using PostGIS to provide or Postgres to provide all the metadata about the data sets that we expose. It certainly makes things a lot simpler, right? You've got one code path through your service.
Right. So, and it's also written in Go. So we did the same thing that we did with PG tileserv. We get native binaries and a container if you want it. We also have a container we put together. But you can just download the binary and Go, and I'll demonstrate that in a little bit. The other nice thing about it, though, is having... the other nice thing about it is just for feature serving, right? So it doesn't have a lot of other... It's not like the other big geospatial servers that shall remain unnamed, that, you're spinning up something that does a whole bunch of, say, X objects in the background and doing a whole bunch of, like, it has to integrate with a desktop suite, or it has to spin up this whole security layer and then an integrated security layer and then a WPS layer and all these other things, right?
Yeah.
So,
yeah.
That
microservice approach.
Yeah. So it can be for microservices if you want it, but it can also just be, I just want features, right? Like that's all I want, right? Yeah. And because I think I think between tileserv and featureserv, we've hit a lot of the only thing that we haven't hit with the spatial suite is a base map layer, right? But you could you could conceivably do that in tileserv if you wanted to. But yeah, but the other part that we could do that kind of gets you the WPS stuff is, can you talk a little bit about functions in featureserv? And you'll demo it later, right?
That's right. Yeah.
Okay.
So, I mean, one of the great things about Postgres is you can run functions in the database. And so PG tileserv and PG featureserv can let you expose functions as sources for the data that they deliver. Right. And as we'll see later, that gives you pretty much infinite flexibility to do all kinds of interesting stuff.
Right. So you can actually do a poor man's WPS with featureserv, right?
Yeah.
Yeah.
And a lot easier than WPS.
Yeah, exactly. Right. You just write it, and because it's Postgres, you can write that function in PGSQL. Sorry. Right. You could write it in Python. You could write it in Java. You could write it in R. You could even write your functions in R as long as you return the right payload, right?
Yeah, exactly.
Okay. Yeah. So how about we demo it? Sound good? And then we can talk. You can talk more about it. While I'm getting ready to demo it, you want to talk some more about your feelings about PostGIS for the web? Like, are you excited about it? What do you think about it? Like,
yeah, I'm really excited. I mean, there's so much power in PostGIS, and that sort of last mile problem. How do you get that data out onto people's screens?
Right.
You end up having to run, potentially big, complicated stacks of things to do that. So we really wanted to slim that stack down as small as it could be, and make it really easy to expose anything that's in your PostGIS instance.
Okay.
So,
I think it's a great idea. And I forgot one of the biggest points. Not one of the biggest, but another huge point about pg-featureserv. You want to talk about this? Can you see it on your screen? No, I'm not sharing with you. Sorry. And you're not watching the stream, but everybody else is. It's the OGC API features part 1 core.
Right. Yeah. So I mean, the OGC specs have obviously been a really key part of spatial adoption for many years now, but they were getting long in the tooth. Everyone was going REST and JSON, etc. So finally, OGC has really committed to modernizing all their specs, and I think this is the first one out of the gate, pretty much. And
the spec is the first modern spec out of the gate, or this is the first implementation of the spec out of the gate?
The spec, I think, is the first real deliverable of their modernization process. There's a bunch more in the works. There's one for tile serving and one for map serving, and I think there's one for processing as well.
Okay.
Coming down the pike, but this one is very key, and so yeah, I think our decision to follow that as the standard is a really good one.
Yeah, and one of the key parts about this is like modern web, right? It's like, I know I'm going to get into trouble with Sean Gillis right now, but it follows REST ideals. Let's just say it's not. I don't know if it's pure REST or not, Sean. Don't come after me for this, right? But it follows the REST type ideals rather than the longer URL passing about. It's more like a developer would expect working against a normal REST service nowadays. Is that would you say
exactly.
that?
Yeah.
And
nice simple URLs, and you get GeoJSON back, so everything can consume it.
Now, just to make it a little bit more debatable, though, is that GeoJSON include a projection information or not?
Well, ours doesn't at the moment, and that's according to the spec.
Okay.
Which is a little unfortunate, I think.
I think so too.
And we may have to look at extending that a little bit, or going back, because originally GeoJSON did provide a CRS, but
yes, as I think it still should.
Yeah,
you could say if it doesn't have one, then you can assume it to be this, but if it has one, accept it. It's not that big a deal. The other thing I wanted to talk just quickly, one last thing on the OGC thing, and then we can put that to rest, is did you find that there were things that you needed to add in addition to the spec because the spec wasn't really complete? Like, because a lot of times specs are developed kind of in committee with like a prototype, but then when you go to actually build something real and go against customer use cases, you see, it'd be just really nice if we just added this. Like, did you find any of that when you were doing it?
Oh yeah, for sure. And to be fair, it's the 1.0 release of the spec, and it's the core, and they know that there's things not in there. I mean, things we added was like an order by parameter, which is really useful to have. The other thing would be really nice is an extended query language, and that's actually being worked on. There's being talk of using a JSON CQL kind of format, which may or may not be a good thing, but if it's standard, that's good. And we threw in a few extra goodies, like a precision parameter to control the precision of your GeoJSON output. Some pragmatic kinds of things.
Right. So basically, so that you're not, if you don't need the precision, you don't have to spend all that data coming down over the wire, right?
Yeah, exactly. I'll demo that.
Okay. Cool. Okay, so then now I can get to the demo, because now we've covered all the major, I think, talking points. It's simple, it's easy, quick. I'll demonstrate how quick and easy it is to set it up. You can do functions, basically WPS, the OGC stuff. Let's do it. Let us do it. So the first thing, again, like we did with Paul, I am going to make this bigger first. I'm going to, actually, I'll move us out for now. And I'll do this. Okay, so the first thing we're going to do is we're going to start up a container that has, this is the Crunchy Postgres app dev container. It has PostGIS already in it. And it'll make a database called scdata. The name of the container will be scdata. And PostGIS will already be in there. So there, we've spun up the container. We've got PostGIS up and running now. Then we're going to go grab some data. So I keep looking, or pausing for a bit because I've got a script of where all these things are because no one likes watching me put in typos. Let's go back to this. Bring this over here. We're going to go get the data. This is the data we used for our PostGIS day in St. Louis again. Same one we used last time, right? So we're going to download the data, the GZ data, save the file. And then, as I explained last time, getting the pSQL command line utility on Windows is a real pain if you don't want the entire Postgres suite, which I don't because I only run on my machine. I only run Postgres in containers. And I don't want more binaries on my machine than I need. So I have to use Windows Subsystem for Linux to get my pSQL command line. So that was put in the downloads. So we'll go cd mount. I probably should make this bigger. There we go. cd mount. C. No, it's lowercase c. Users. Steve. Download. Oops. Downloads. Okay, so we'll do an ls, shell t, and there should be our SQL fire dump. Yep, there it is. Now let's import that so we can just run this little command to import all our data. Again, this is, I'll put the link to the data in the show notes in case you want to try this yourself with the same data. It's some fun data. So now let's go back to here and paste that in. So we're going to unzip the data but pipe the output. Rather than to files, we're going to pipe the output to the pSQL prompt to just import it all, right? And we're going to do that as the user Postgres, and the password is password, because I didn't type it right, PASSWORD. Oh, because it's not fire data. We called it SE data. You guys, you're supposed to be helping me with the pair programming here. Not you, Martin. You're good, but it's the people on the phone call. There we go. PASSWORD. There we go. So it's importing all the data. All right, all our data is in. Great. Now we're going to go get pg-featureserv. So here's like I said before, the repo is github.com, crunchy data, pg_featureserv without the E for all us hipsters. There you can see Martin's Dr. JTS, all his stuff being put in. There's instructions on how to run it right here on the page. We just want to download the Windows version, right? So we'll save that. No, let's open it. And so you'll see the contents of the zip file, our assets. That directory contains like all the stuff needed to render the web pages that it renders out of the box. The config directory where we can put a TOML file to do configuration, but we don't need to start with. And then there's the actual binary right there. And then we'll extract all of this into our downloads directory. So it's all our stuff is in one place and it's easy to clean up. There we go. And there it is. And so there's all that stuff in that directory. The one thing you do need to know is that the assets directory needs to be in the same directory as the pg-featureserv. Unless can you specify, Martin, is that something you can specify in the TOML file that it can be in a different location? I can't remember.
Yes, you can.
Okay, so, but by default, it expects assets to be in the same directory, right? But in the TOML file, you can say my assets is somewhere else, which is also a nice thing if you're doing something like cloud, because you could put it on a volume mount and then it's always the same volume mount for all of them, right? Which is nice. Anyway, let's go ahead and see what we got. Let's open the command prompt. So there's the command prompt and I try, let's go to make it bigger. There we go. And we'll go to downloads and then we'll do pg-featureserv. And like last time with tileserv, it says, great, I'm going to try to start up. Oh, I can't have a blank DB connection. Like this doesn't work, right? Give me what database am I talking to? And so like last time, we can just set an environment variable. This is the easiest way, though I don't know this is always what you want to do, but we can just set an environment variable. We'll set the environment variable as database_URL. You can also configure this in the TOML file if you want, but there's our database. We're going to connect as user Groot with the user. This is basically a standard PostgreSQL connection string. So username Groot, password is password, localhost is where we're connecting, and the database is SC data. Now that we do that, we start up pg-featureserv. Boop, and we're done. It's running. Like you just stood up the server. So if you already have data in a database that you want to serve up, the only thing you have to do is download the binary, set the database URL, and start the binary, and you're done. And you can do this on Mac, Windows, or Linux. The binary, that's the nice part about the Go that Martin and Paul both talked about, is we can compile to native binaries, which I think is awesome. There's nothing in my registry now. I didn't have to put anything in my registry, and I could put this in user space. I didn't need an administrator to go ahead and install this for me. I could just put it in user space. After Paul's show, someone was complaining that Symantec and Norton didn't really like running pg-featureserv or tileserv in their case. The reason why is, my guess is because we're opening up port 9000 to accept incoming requests. Opening up high ports, which you can do as a non-privileged user, so again in user space, is usually the sign of a Trojan, right? So Trojans, when they're installed on a machine, will open a high port so that they can actually go and start talking to their master server, whatever you're going to call it. Or the coordinating server. So that's probably why those don't like it. They're like, what is this binary that you're starting that's trying to connect on a high port, right? So, but you should say it's okay. That's my guess. We don't know of anybody making any other commits to our databases, or to our GitHub, I should say. All right, and so with that done, this one's on port 9000. I think that's because Martin is so awesome. He's like, this is over 9000. For those of you who like web memes.
Probably would have been better if that was synced up with tileserv a little more. Yeah.
No, you shouldn't, because then you couldn't start both at the same time.
Well, no, I mean just have it one different tileserv.
Oh, one different, yeah. Okay. Yeah. I don't know. I like 9000. It's over 9 because I get to say it's over 9000. All right, so there it is. There's pg-featureserv, right? So we automatically out of the box we get this. We get the Open API schema, right? So this is actually, Martin did the really nice work of integrating with Swagger and Open API, which is now Open API. So if I click on the JSON for this, we actually get the JSON that shows this is an Open API doc, right? And so one of the nice things about that is you can actually click on the Open API schema itself, right? And there is the nice Swagger doc that actually shows what's going on in so you can see all the URLs like a normal web developer. This is exactly what we were talking about, like dealing with an API now. You could point your Open API bindings utility, like let's say you were going to use Ruby for some reason. There is an Open API Ruby interpreter. They'll make Ruby bindings. You could just point it at this doc, that JSON that we saw before, and it'll generate all the bindings for you in Ruby to be able to work against any of this stuff. So all of that, this is the modern web benefit that we got by OGC moving to the spec and us adopting it as well, is all that Open API goodness that's in the world, you can just inherit that right away. So, and you can actually go in here like get collections, right? And you can say try it out, and you can say execute, and it'll respond with the collections, right? So there's the request, and there's 200, and there's all the collections that are in my database, right? So you get those right away. So for you developers out there, this is a huge win over anything that you've used for feature serving before. Now, let's go back. We can actually view what collections we have. So here's all our collections. We have the same as last time: assessor parcels, county boundaries, facilities, fire service areas, all the things that we want, points, lines, and polygons. And again, it used the metadata in Postgres to say, does this have a geometry column? If so, can I see it? And I can see it? Great. I can serve it up then. And so we won't start with assessor parcels because that's big again. Let's start with, let's do the fire service areas. So we'll start with that one. This basically, you click on that and you get the metadata for that feature layer, right? So you get the extent, you get the SRID that it's in, you get the fields that's in there, right? But then if you actually want to view the items on a map, you click on it and you get the fire areas, right? So there's all the fire service areas. And you can, again, since these are features now, you can actually click on them and get all the information about the features. And if you click on this box right here, well, let's click a smaller one. Let's pick this one. And if you click on this box right here, it zooms into that feature, right? We also have the ability to rezoom to the whole layer. You can actually also limit the number of features that we won't see that. That doesn't matter in here. And you can also click bounding box. And I forget exactly what bounding box does again. Can you remind me? Oh, it's the bounding box of the currently drawn features, right? Zoom to that bounding box.
No, it's the bounding box of your map view.
Oh, okay.
So it adds the bounding box of your map view to the query. So.
Oh, nice. So if you're zoomed in, you only get features in that area.
Exactly. Yeah.
Oh, so we could do that. Like if I zoom in here, right? So I don't get all of them. Let's go down South County in Santa Cruz, and I'll go here and I say requery again. Oh, it went out to the whole limit though. I don't know why.
Probably.
I didn't change the number of features, probably. Let me change the limit of features to 10.
Maybe.
Let's try that. Let's see. Ready? Go. Nope, it zoomed out of the whole county. We'll deal with it later. All right, so let's go back and look at a big collection now, though. Oh, we can also do streams. So here's all the streams, right? So if you want to view them. But so you're like, wait, there's more streams than that in Santa Cruz County. And you are correct. But notice it says feature count is 10. We don't want in the default view to start with to overwhelm your browser, right? But we can change this to 1,000 if we want. And it's that fast, right? That's 1,000 features getting streamed back. That's part of the power of, let's do 10,000. Boom. 10,000 streams. It's still more than that in the whole county if we wanted, right? The other thing you can do is you can actually, let's go back. If we do the streams again, you can also click on the JSON, and this should give you the raw data for the streams as a GeoJSON. It's the location of it. Oh, right. Hold on. Let's go to the JSON. And if we go here and we want, because this is good, here's how you actually get the items, each of the individual ones. This is the description of the whole layer, right? If I want all the items, I can open that link in a new tab. And that is giving me back there's all the JSON for each of the streams, right? So that's how you go about getting back the raw GeoJSON data. You can also get that as HTML, right? And that brings back that's just for the metadata though. Right? You can get that as HTML if you want. So let's see. What else? Do I have anything else to show here? I think, I want to show you the parcels again, right? So here's the parcels that we did last time as a feature layer, right? So this is what we did with TileServ. We gave back these parcels. In this case, I want to show that modern browsers and modern streaming and all the modern JavaScript and all that can actually, so it starts out with 10. That's 10, right? What I can do is change the limit to 10,000 and requery. There's more than 10,000 features in the browser right now, which in older browsers would have actually killed the browser right away. And that was actually really fast these are generally pretty simple polygons, but still we can get 10,000 wherever we are. So I think here we go, 10,000 limit bounding box now, and we requery. Now it's doing what Martin said. Now you see it's getting us 10,000 from downtown Santa Cruz, right? And again, we can get all the feature information. So I think that for me as an end developer, this is freaking awesome, because a lot of times all I want is something that just streams features out of my database in JSON that I can then do stuff with and put on top of a map. And I got that without having to write any code. I just execute one command and I've gotten it. So from simplicity and ease of use, this is freaking awesome. Oh, you guys probably want to see, how much memory am I using up? So let's bring my task manager over. There's our command prompt again. We're using 35 megabytes of memory right now to serve up 10,000 features, right? And it's currently 0 CPU. I think if we tried to be really quick about it, we might, let's go back out to the whole requery, right? So let's limit it to 10,000. I don't think I'm going to, I have to do this. There we go. Drag this over here. Okay, watch the CPU. I don't know, requery. So it went up to I think we maxed at like 1% CPU to bring back 10,000 features, right? And that's with the PostGIS database running on the same machine as well, right? So think about that. So we're using 35 megs of RAM and 1% of the CPU to render and return 10, and the browser. At most, we went to 1% for the whole thing, I think. Well, Firefox is a hog, but so is Chrome. Anyway, I'm going to turn it back over to Martin now, because Martin is going to show you this part, which I do not have, which is functions, which is the cool part that we talked about before about, I have to actually make Martin the host so that he can share his screen. So Martin's going to show off all the cool high-end stuff. I'm the simplicity guy, the easy stuff, and Martin actually shows off all the really high-end cool stuff. So off to you, Martin.
Okay, I'll just share my screen here. I just have to find my Firefox. Can you see that?
Yep.
Okay. So I have a whole ton of functions defined in my PostGIS schema. So here's a list of them here. And so with functions, you just define a Postgres function. If it returns they return records, so you can return multiple data items for each record. And if the record contains a geometry, then that's a spatial function, and you can see it on a map view. You can also have functions that don't return geometry. They just return attribute data, which can be pretty handy too, and I'll demo one of those in just a sec. So let's pick this one. This is, I have a natural earth data set of countries loaded up here, and this function lets you find countries by prefix. So if I do prefix ch and then requery, I get back China and Chad and Chile. So, and I'll show you the definition of that function. Let me just, I just need to switch my screen here. Where are we? Oh, it didn't work. Try that. Switch over to here, and I believe this is it right here. Yeah, so you can see the, here's a pretty simple little function. It accepts a variable called name prefix with a default, and then it just queries the functions using a like against the countries table. Let's go back to the service view there. So another example is country by location. And for this one, I'm just going to enter a URL for that. Now this is a non-spatial function. So I'm going to do, I have this query here. Dump that in. Yeah, so you can see I'm querying the country by location function, asking for the items, and I provide a Latin long. And what that's going to do is return the country record that's at that Latin long. So it does a point and polygon query to get that inside the function. And when I do that, now because this is what it's returning is just the 3 attributes from the function, the name, the abbreviation, etc. So it can't show a spatial view because there's no spatial coming back in the JSON. And let's try another example here. Oh, this is a fun one. The Geonames Query. So we have the Geonames for the US data set loaded up, which is a data set of about 2 million points. And we can query them by strings that are in the name. So if we do, let's say, notch, and we'll set a pretty high value on that, and we'll go off and run the query. So it's going to return all the geonames, geoname points that have the word notch in them. And as you might expect, there's a lot more notches over in the Northeast US.
Is it, so what language does that come from? I know Smuggler's Notch in Vermont from skiing, but I wonder what notch is coming from.
Well, I assume that's an English word, right?
Yeah.
So,
for a gap. Instead of a gap, it's called a notch.
Yeah, exactly. Yeah. Let's try gap for grid.
Yeah.
You can have a lot of fun querying this.
I'd spend hours doing this.
Yeah.
There we go.
Oh, I didn't do a very big limit on that. Let's see what happens. I bet you
there's a gap. There's a gap all the way out on the end of the Aleutians.
Yeah, exactly. Yeah. Oh, look at that. Lots of gaps.
Lots of gaps. That's a much more common word, huh?
Yeah. And lots of gaps. You notice there are lots of them in mountainous areas, right?
Yeah, exactly. Like there's the Appalachians right there, right?
Yeah, exactly. Yeah.
So what's that gap in the middle, like over Oklahoma? What mountains are those? Are those
is this Oklahoma here?
No, Oklahoma's down below. See it? There. We're in Oklahoma. I wonder what chain is going through there. That's interesting. I didn't know.
Down there. Is that the Ozarks?
Maybe? I guess it's got to be the Ozarks, right?
Yeah. Sugar Gap. Oh, Mountain Gap Church.
There you go. Nice.
Great.
Right. And so, are you using full text search behind the scenes on this one? Do you know, or are you just using an highlight?
No,
Yeah.
I'm using full text search, which is why it gets screaming fast performance.
Yeah, and you can do all sorts of fun stuff. So this is an example of not just using PostGIS stuff in your functions, but actually using all the power of Postgres with
Exactly.
PostGIS to get this really cool this thing, right? And so,
Yeah.
and the other nice part is once you've written this function, none of your web developers have to learn how to write PostgreSQL functions, right? You write the
Exactly.
function, they just have a URL they call with the names they want, and they get back features that they can just put pins on a map. So
Exactly. Yeah. So really, this is web processing basically.
yeah, totally.
Simple web processing, and the fact that you can also do non-spatial data
Mm-hmm.
sets really makes this a pretty general purpose interface to your database.
Totally, because you can do it with. You don't have to just do it with. What? So here's a question though. Oh right, because it's just a function, right?
Mhm.
So it doesn't. It's not tied to any particular table. So it's anything in your database could be exposed through through those functions, spatial
Yeah,
and
that's right.
non-spatial data.
What
Right.
what we do is all the functions we expose are defined in the PostGIS FTW schema.
Okay.
We can't expose every function that's in the database because there's a zillion of them, right? So
Right. 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 Because then you'd also expose all the PostGIS functions as well.
yeah,
Right.
and all the Postgres functions, and yeah, it would
Right.
be crazy.
Right.
Yeah, so I think that's mostly what I have.
Wait.
I'll do one more here. Here's a GeoGrid. Let's do this one. So, oops, what?
You stop sharing.
There we go. So actually, I'll better up my limit here. So what this does is it generates.
Oh wait, you're not sharing anymore, Martin. You click something
Oh, I'm
that
not.
stops
Oh,
you from
okay,
sharing.
okay. I lost my share. Let me get that back. There we go. You see that?
Yeah.
Yeah.
Oh, look at that nice Mercator distortion.
That's right. Yeah. I didn't say this was a useful example, but
No, this is actually this is highly useful because this teaches people like this is a great example. These are all 1 degree. Are these what are these like 5x5 or something?
Yeah, they're I think they're 10 by 10 actually in this case.
Okay, so 10 degree by 10 degree grid, but then it gives people the sense of like, yeah, you see what's happening to these squares? That's what's happening to Greenland. That's why Greenland's so damn big.
That's right.
And not to throw shade at Canada, but it's also kind of why Canada is so damn big.
Yeah, that's right. Canada's actually a lot smaller than it looks.
Yeah.
Yeah, I mean, this could actually be practical if you wanted to generate a grid for use in a web map.
Right.
You could also generate hexes like Paul showed in his TileServe demo.
Right. And the function could actually do the aggregation counts and return features with the aggregation counts in them, right? If you
Exactly.
wanted to as well.
Yeah, and then you could color theme on your web view side, and you have a pretty nice map.
And at one point we should probably have. This is a larger question because I'm just thinking about like, so why would I use? And I don't expect you to have the authoritative answer because I'm sure the answer is it depends. But why would you use feature-serv versus tile-serv or tile-serv versus feature-serv? Like, where do you see the cutover between the two? Because you're just showing this is the same as Paul's example. Why would you do yours rather than Paul's? Let's say you use feature-serv rather than tile-serv for the same thing. Do you have a sense of that?
Yeah, well, obviously TileServe, like for say displaying the parcels in Santa Cruz. I mean, TileServe is going to give you a smaller payload and render faster, etc.
Okay.
So you'd probably want to use TileServe for showing parcels. But the line, I mean, as you said earlier, right? Modern browsers and fast internet, the line is a lot blurrier between when you might want to do features and when you might want to do tiles.
Right. Because when you have features, you have actually individual features you can do things with on the client side, right?
Exactly.
That haven't been chopped up, right?
Yeah.
So we do get features back with Paul's, but they've been chopped, right? So it's a little bit it's a little harder to work with them. Would that be right?
Yeah, exactly. Like you couldn't say buffer them or
right,
really compute their area, etc.
Right. You'd have to do that server side and then return the value.
Yeah, exactly. Yeah.
Or unless the area was an attribute already inside it, and then you could see it. But if you couldn't compute things on the fly with them that way.
Yeah, exactly.
Okay.
Yeah. Oh. But there's a lot of crossover there. So
yeah,
I sort of went to that myself, and really it's it just sort of depends on use case, I guess.
Yeah, I mean, as in most things in technology, right? It depends.
Yeah.
Right. So there's no like feature serve all the things.
Yeah.
But I think that was really awesome. I mean, like the amount of functions you could do here is just kind of limitless in terms of getting data, and it's basically. So here's one of the debates. So you can turn off your sharing now so that people can see us again. Because now I think we're done with demos, right? You think? Anybody in this chat want to see anything else that you saw on Martin's list of the? Go back to your list so people can see. Oh, you took your list away. Put your list back up. Put your list back up of all the different functions you have.
Okay.
Yeah.
You got to be careful with that because I know some of those functions are sort of really prototype and some of them don't work. Like unfortunately, the hex grid one, I was kind of kills my PostGIS instance when I run it because it generates way too many hexes. So.
Okay, so you did. Okay, so never mind. You guys, you get what you get, and you don't get upset. All right.
Yeah.
Let's go. Let's go back to the discussion. This is the discussion I think that we had, where me being more of a programmer guy, I would say, in terms of app programming, not necessarily. I mean, I know you're programmers and stuff, but I want to write my own REST services. Right? Like I want not necessarily this. I would love to run feature serve because then I don't have to write all the spatial, really hard spatial things. But you and Paul both pointed out that basically what you've written is a function to REST engine, right? Like basically I don't have to if you wanted to, you could use feature serve so that you did not have to write anything that calls into the database and returns data. Like you could just
and in fact, you can also use feature-serv as a way to update. Right? Yes. You can pass in parameters to a function, and the function is going to go off and update.
Yes.
What you want it to do.
Which again brings up the point of only give access to the things that you want to get. But we could handle that with feature-serv, right? Like you could have two feature-serv instances running. One which is a read feature-serv instance and is available to the outside world, let's say. And then you have another feature-serv instance running that is the account for that one is one that has write privileges, but that's only available like within the firewall or to some sort of approved list of IPs or something like that, right? So you can handle that. But so the point being, and so this is where, and I would love at some point if either in the show notes or in the comments down below or even now, where people like just give their gut feeling about like, would you just write database functions and use pg-featureserv to just do that? Like I was like, no way, I want to write my own REST services. And Paul and Martin are like, why? Like you could just write a function and then you have it. Why write it? The server can do it. And you saw how fast and small it is. So it's a really interesting debate. And I think some of it comes down to emotion actually. And like what you feel comfortable with.
And what your current stack is. And
yeah. But I just think that's an interesting thing that people may not have thought about with feature serve and the flexibility that you get with it. That you can basically not write REST services anymore. Just basically write database functions and you get an instant REST service out of it.
Yeah. So, and there's, that's certainly a trend, right? With Hasura and the graph, I guess that's the GraphQL server, Postgres, and
So I get that is a trend, but then I can't use my IDE anymore, and you're gonna cold pry my IDE out of my cold dead hands, which isn't far away. So maybe soon. But anyway, so I think I don't think there's anything else you wanted to talk about, or do you think? I think we did a really good job. I think we did a bigly job of showing off feature serve. I hope people really enjoyed that.
I guess a few of the things we've thought about adding. One is update, like actual update through posting data to the service. And using post and put, etc. So making it a full-blown REST service.
Right, and that would be an extension of the API, the OGC, right? Like OGC doesn't cover that use case, does it yet?
Actually, I'm not sure. They might have that in there.
Okay.
They might have that in there. They're definitely heading that way. They want to be a full-blown RESTful service.
Right.
Yeah. And let me just quickly. I had some notes here about what might be coming up next. I'd like to add a more full-featured query language, I think, and then temporal handler. That's one thing that is in the spec, which is a ability to specify a time range for your queries, and so we'd like to add that as well.
Okay, cool. I think people would that whole spatial temporal, it's the bomb, right? People really feel like that they want that.
Exactly. So,
I think that would be actually really interesting, especially with some of the work that's happening with time series stuff in Postgres itself too. Right? Like a lot of people are starting to push that with the partitioning and everything. So that would be really interesting. I also think one of the other things we've talked about a bunch as a group in the spatial team at Crunchy is how do people handle security, right? So most of you probably work in enterprise companies and you have some security protocol. So we were going back and forth arguing different things. So there's two different main approaches we see. One is an API gateway. So you would stick feature-serv behind an API gateway, and the gateway would handle all the authentication and letting requests in and out as you would approve. And then the other one is some sort of like OpenID Connect integration points. Like you could plug in some OpenID Connect server, and then you do all the token passing and stuff like that. So if you feel like it, in the comments, we would love to hear about what your company's doing in terms of OpenID versus API gateway. Because we don't want to do anything more particular, like your specific Kerberos integration. That gets really complicated. I mean, you could do that. The source is open, and you can add that in your version of feature-serv. I don't think we're thinking about that at this point, unless you come with a whole chunk of cash about adding that kind of deep integration into Kerberos. We're thinking more of like large patterns that gets us a whole bunch of really good modern web practices. Which is either API Gateway or OpenID Connect kind of server integration. So I'd love to hear about that as well. With that, I think we're going to wrap up, I think. Sound good, Martin?
Sounds good.
Okay, thanks for coming. It was a lot of fun and hearing the history of your Java expertise. And also, I would like, is that professor still a practicing professor or doctorate or whatever?
He is still working. Yeah, he's working with the Canadian federal government on what's called the National Hydrographic Network,
Nice.
Which is a data set of all streams and lakes in Canada.
Okay,
and
so,
actually the US too. It's sort of a joint effort. So.
Nice. So it would be great if we get some sort of URL for the show notes so people can read more about this wonderful individual who has enabled. So is he in Victoria as well?
He is in Victoria. Yeah.
So everybody likes to talk about what's that geospatial school in Newfoundland that everybody seems to want to go to. Is it in
or New Brunswick, I think.
Yeah, or New Brunswick. What's it?
Yeah.
Do you remember what it's called?
Yeah, I'm not sure which.
Well, whatever it is, they're posers. The real powerhouse for geospatial in Canada is in Victoria, British Columbia. It's amazing how many geospatial on that island itself and in Vancouver a little bit. It's really like that area. It's amazing all the
especially
geospatial stuff.
I mean, it's not quite so much anymore, but back in the 90s, yeah, it was there was a lot of stuff happening here.
Right.
A lot of really interesting initiatives coming out of here.
Okay, cool.
Including PostGIS.
Yeah, exactly.
Yeah.
All right. Well, thanks everybody. Thanks for joining us, and I'll be back again soon. We'll see what the next one's. I think maybe the next stream I'm gonna do, unless I get somebody from Crunchy to come on with me. I'm trying to get Joe Conway so we can talk about PLR, which is putting R into Postgres. If not, I'm going to be talking there was a lot of positive response to me doing entity relationship modeling and showing off PG Modeler. So I'll probably do a stream on that. And then Stephen Frost just recently wrote a Katakoda. So in that learn.crunchydata.com, he recently wrote a class on lateral joins, which Martin is a big fan of after having learned about them. But they're really hard to get your head around, I think, as a normal developer. Although they're not, once you get them, then you're like, oh, why? But then it's also hard to use them. So I may do a thing on lateral joins because they're super powerful, and we have a class on them now. And I'd really like to see people start taking advantage of it in Postgres. So with that, we're gonna cut out. Bye, everybody.
Shut up and sit down.